Hi, grade 10. I did a live lesson about 10 minutes ago, and unfortunately it didn't record, which is a bit of a bummer. So I think I will just redo it as efficiently and as effectively as possible. You might have missed something. It is very easy to miss something. So here we go. I can go a little bit faster because I think all of you were in the lesson bar 2 people, Rhoda and Lou. So if you do speak to them, give them a bit of help if they need it, or find out why they were missing. So I'll start off by explaining the triangle. So if we look at question 1, it says given that sine theta equals 5/6, and it gives you the range of the quadrant 0 to 90. So you can think about this in relation to the unit circle. It's saying from 0 to 90, which is obviously this quadrant in here. And it's saying that sine theta is equal to 5/6. Now, what you need to remember is the trig ratios, which say that sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. You've got these, which you're going to be using throughout this exercise. So if I draw this triangle, it's telling me that the opposite is 5 and the hypotenuse is 6. So it's telling me that that's 6. It's telling me that the opposite of 5, and here is theta. So using my Pythagoras rule, I can work out what the adjacent is by just doing the square root of the hypotenuse squared minus the opposite squared, and that gives me root 11. So now I can work out all of my trig ratios. So if I want to work out cos theta, I know that's adjacent over hypotenuse, and if I want to work out tan theta, I know that that's opposite over adjacent. So then it says work out the exact value of each given the range, and I think in the class I did cos 2 theta, so I'll just do that one again. And now we have to look here for what are the equations. There are 3 equations for cos 2 theta. Cos squared theta minus sine squared theta, 2 cos squared theta minus 1, and it's also equal to 1 minus 2 sine squared theta. Because I know sine theta and I know cos theta, you can actually use all 3 here. You don't need to work out the other ones if you didn't want to, but because I'm starting from B, you would have already worked out what cos theta and sine theta are already. So you can use any. So I'm going to choose the last one, 1 minus 2 sine squared theta. So I think Anna asked me in the live chat, why did I choose that one? Well, I just chose it because it gave me sine. So if I had made a mistake and calculated cos wrong, then at least I know I would get this one right because it's already given me sine. So 1 minus 2, 5/6 squared, because I know that sine theta is 5/6. So that's 1 minus, and 5 squared is 25, times 2 is 50, and 6 squared is 36. I'm going to simplify that down, so that's going to be 18/18 minus 25/18, which gives me negative 7/18. Now, just to show you that it works for both, if I try another formula, cos 2 theta, and I'll try the one I didn't try in the video, cos squared theta minus sine squared theta. Now this one, from my experience, is the one that's used less because it's got both in it. But it's nice to try it out with it, see what happens. So I know that cos theta is equal to root 11 over 6. So that's cos squared theta minus sine theta, which I know is 5 over 6 squared. So that's going to be 11 over 36 minus 25 over 36, which is going to give me negative 14 over 36, which simplifies to negative 7 over 18. So there I've shown you that you can use multiple. Now, Noor asked me at the end of the video, what do you do when you've got tan? So I'll just re-emphasize that again. When you've got tan, you need to remember the trig identity, which says tan theta is equal to sine theta over cos theta. So therefore, tan 2 theta is equal to sine 2 theta over cos 2 theta. Now, if you calculate A correctly, you should know that sine 2 theta is equal to 2 sine theta cos theta. So you can work that out because you know sine theta and you know cos theta. And we also know that cos 2 theta is negative 7 over 18. So when you work out the answer to 1a, you put it in that box, and then it's just dividing fractions. Keep, change, flip. So another way of writing it, it's this fraction times by 18 over keep, change, flip. Right, I'm trying to keep it as short as possible without rambling. I think that's me covered everything. Just remember to watch out for your ranges. When you draw that, because it's got a negative, it's in the other quadrant. But your triangle will, if I do it down here, your triangle is going to end up in this quadrant. But because it's cos, it's symmetrical, so it's going to be a 2 here and a 3 here. So your angle is obviously bigger than 90 but less than 180. But if I was to do it in the positive quadrant, then this angle is obviously the same as this angle. Okay, people, I think that is everything covered. Oh, yeah, forgot about this, the book method. So although I draw the little triangle, the book also uses this formula, sine squared theta plus cos squared theta equals 1. So if you know either sine or cos theta, you can also work out one or the other. So to back up question 1b, which I done above, it said that sine theta was equal to 5 over 6. So if I put 5 over 6 here, then I can just rearrange it to find out what cos is. So it's 1 over 25 over 36, which is going to be 11 over 36 is equal to cos squared theta. So cos theta is equal to the square root 11 over 6. And that backs up what we were saying. So the book likes to use this way sometimes, but my favourite way is to just draw the triangle and get your opposite, adjacents and hypotenuse in, and that way you can use the trig ratios, so you know each one, and then you can use the double angle formula. Happy math exercise! Remember to put your class notebook nice and clear.